Okay, so we are going to be going through how to graph exponential functions. This is just review. So we learned this in year 11 methods. So this is just working out of 5A from the Cambridge textbook. So we need to understand the basic exponential function. So if A is greater than 1, it's going to be getting exponentially bigger as x goes to the positive area. And likewise, if we have A is greater than 0 but less than 1, again, it is going to be getting exponentially smaller um, as we get into the positive direction. So really, it just looks like we have flipped them around. So to understand transformation, we need to be looking at dilation, reflection, and transformation in this order. We can flip between reflection and dilation, but transformation has to be last. So if Dr. T helps you, keep in the back of your mind, Dr. T. So let's start off. So we've got um, f of x is equal to negative 2 to the power of x minus 3 plus 4. So the first thing I'm going to be doing is we're going to be looking for the sequence of transformations that map y equals 2x onto f of x. So if we're thinking about Dr. T, dilation, we've got no dilation that is happening here. So then I go on to reflection, and I can see I've got that negative 2 there. So that means I have reflection in the x-axis. Then I look at the transformations. We've got horizontal, which is affecting it up here. So that means that's a shift by 3 units in the positive direction. And then we've got our vertical, which is on the outside here, the plus 4. So again, we've got a vertical shift by 4 units in the positive direction. Now, this here really helps me understand where my asymptote will be, which is where it helps me work out my range. So with the plus 4, that's where my asymptote will be. It's reflected, so it will be all the way down in this area here, which means I know it's going to be negative affinity to 4. Now, it's whenever we're graphing, it's about going back to your basic graph and doing it slowly. I like to focus on my original graph. That means my original graph is I've got an asymptote at y equals 4. I know it's going through 0 and 1. The next part is reflection. So that means it's going to be reflecting in the x-axis. So now it's going through 0, negative 1. Then I look at the translation. So that means I've still got the original point that I've started off with, 0, negative 1. I know it's going up 4 units, and then I know it's going across 3 units. That gives me my next point. Now I need to know my x and y intercepts because I know it's going to go through those axes. So x-intercepts means I need to make y equals 0, which gives me 5. For the y-intercept, I need to make x equals 0, which gives me 31 over 8, which goes right here. Now I've got those 3 points, I can accurately draw my exponential function. Let's look at the next one. Apologies, I must not have animated it properly. I've got an asymptote there. So the first thing I need to do with f of x is equal to 3 in brackets half to the power of x plus 2 minus 1 is think about what is happening in terms of transformation. So the 3 there is a dilation and it's doing it to the y values. So that means it's a dilation factor of 3 from the x-axis. Oops, sorry, I spelled axis wrong. The second part is I look at, do I have any reflection? There's no negative here, so there's no reflection. I then look at the horizontal shift. So I've got here, which means it's a negative 2 units in the negative direction, and I've got a vertical shift down by 1. So this helps me go to the next step. So in terms of the range, I look at where my asymptote is. It's -1, so it's going to be greater than -1, but it can never equal that amount. And it's going to go all the way to infinity. Now, if we look at the next part, which is graphing, I want to straight away look at what does my graph look like. Um, so first thing, the basic graph, because of my A here is less than 1, I know it's going to look at this as my basic graph. I've got an asymptote at y equals 0. It's going through 0 and 1, but it's flipped compared to what I had previously. The next part I want to look at is the dilation. So the dilation, the 3, means whatever this value is, I'm timesing that y value by 3. So 1 times 3 is 3. So that means I am then pushing that up. The asymptote stays identical. Okay, the next part is I need to look for what's going on in terms of um, my my translation. So straight away with my translation, this -1 means the asymptote's pushed down, but I've got this point pushed down by 1, and then it's going across by 2. So that's what I've got here. Horizontal shift by 2 units in the negative direction, and vertical shift by 1 unit in the negative direction. Now I've got those two translations done, I can then put my point here of -2 and 2. Before I can graph, I need to work out what is my x-intercept and what is my y-intercept. So an x-intercept is I'm making y 0, and I'm just solving it on the calculator, and it gets me -0.41. Likewise, my y-intercept, I'm just making x equals 0. If I make x equals 0, I am getting y is -0.25. That gives me these 2 points when now I'm able to graph. Okay, so let's look at the transformation that's occurring and sketch the graph of y is equal to 4f x plus 1 in brackets take away 2. So, and our graph is 3 to the power of x. So the first thing that I'm going to do is think about what is the transformation that's happening with my basic graph. Well, we've got a dilation of 4. So that dilation of 4 is from the x-axis. The next thing that we have is we've got a horizontal shift of 1 unit in the negative direction of the x-axis. And we've got this -2 here, which is the vertical shift down by 2 units. Now, the next part when we're graphing is I just want to go back to what is the basic graph. We've got our basic graph right here of f of x. It is going through here where x is 0, y is 1. We always apply our dilation first, which means the first thing I'll be doing is going, well, what's 1 times 4? 4. So that's where my graph is already pushed up here. The next part that I need to look at is what is my horizontal and vertical shifts. So I'm just going to be putting that on my graph. So that says a horizontal shift by 1 unit in the negative direction. So I've gone across 1, and my vertical shift is down by 2. That gives me a point that I need. The next part that I need to work out is I'm going to have a y-intercept up here. I need to work out what that is, and it's going to go through here at some point with a x-intercept. So that's a couple of things that I need to find. I've got my asymptote at -2 because that's what it's got up down here. It's my vertical shift is gone down by 2. So let's look at the x-intercept and y-intercept. The first thing I had to do to find those is write my equation. So I've got the dilation out the front times 3 to the power of my horizontal shift, and then I've got my vertical shift. So for an x-intercept, I need to make y 0, and then I'm just solving it. That gives me negative 1.63. And then my y-intercept, I'm just making x 0, and that gives me 0, 10. So as you can see, I won't be able to put my y-intercept over here, but I can show my x-intercept here. The last thing I would need to do, which is just labeling all of my points.